Hi everyone, welcome back to another video in our manual testing series. In today's session, we are going to explore risk-based testing, one of the most effective techniques to optimize testing efforts. It helps to achieve maximum test coverage and quality without compromising on testing depth even when execution time is limited. In today's session, we are going to cover what is risk-based testing, why it is so important, how to identify and assess risks, how to prioritize your testing efforts, and finally how to apply it using a real-time example. Risk-based testing, in short RBT, is a test management approach that prioritizes testing based on risk. The idea here is very simple. Not all part of the applications are equally important or equally prone to the failures. So instead of testing everything equally, we focus on the areas that pose the highest risk. It is a combination of two important facts called as likelihood of failure that tells how often a given functionality is going to fail. The second one is the impact of failure. If this functionality fails, what is the impact on the end user? Before we try to apply this strategy, let us try to understand what we mean by risk. Risk is any event or a condition that may impact your normal activities. It can be either positive, turning to be an opportunity, or a negative, which is causing a threat for your normal activity, or it is going to hamper your normal activity. That is called as negative risk. Positive risk is always turns out to be an opportunities. As I told earlier, risks are typically evaluated along two dimensions. The first one is the likelihood. It basically tells how likely or how often the functionality or a feature is going to fail. Second one is impact. If the feature or a functionality fails, how severe will the impact be? Let me give some of the real-time examples for a risk. In an airline industry, a sudden rise in the fuel prices increase the cost of flight operations. The impact is reduced profit margin or increased ticket prices, which is actually a negative risk, lower competitiveness and customer loss. Similar to this, in manufacturing industry, a key supplier of raw material failed to deliver the components on time. The impact is the production line stops, delaying the delivery to the customer. It is again a negative risk, loss of contracts or financial penalties. On the other hand, let us consider some positive risks. In a manufacturing industry, adoption of sustainable energy like solar panels reduces the long-term electricity cost. The impact here is short-term investment leads to a long-term saving and improved brand image. This is a positive risk because it reduces the operational cost and better marketing positioning. Similarly, in an airline industry, a sudden drop in fuel prices reduces operational expenses. The impact here is more profit per flight. The opportunity is to offer discounted fares. This is a positive risk, higher passenger volume and increased profits. As you all know, the risk has two components, which is called as likelihood and an impact. Okay, now let us try to visualize this using an risk matrix. This table basically shows the different combinations of likelihood and impact. If the likelihood and impact both are at a high level, then the risk level is considered as critical. Example scenario could be an e-commerce application crashes on Black Friday due to the server overload. If the likelihood of occurrence is a high chance because due to the load there is a high chance that server may crash. If it crashes, the impact is also higher. The company can get into a financial losses. If an likelihood is an high and impact is medium, then the risk level is considered as an high. For an example, a software update is deployed frequently and may cause a minor disruption to the customer access. If the likelihood is medium and impact is high, then the risk level is also considered as an high. An example, a key supplier may delay the delivery due to the overseas shipping issues. But in likelihood, it may occur or it may not be, right? We are not certain. But if it occurs, then there is a severe impact on the production line. If the likelihood and impact both are at a medium level, then the risk is considered as a medium. For example, customer support response times may increase in a holidays. Okay, so the likelihood is it is not certain, right? So likelihood is medium. It may or it may not occur, right? If it occurs, then there is a little bit of delay in the customer response that may leads to the user satisfaction, that may affect the user satisfaction. If the likelihood is low and impact is high, then the risk level is considered as a medium. Example, natural disaster risk in a region where a company has its only data center. Now, the occurrence of natural disaster is very low. Alright. So, if it occurs, then the impact is very high because that company has only one data center at that region. So, company is going to lose all its data. If the likelihood is low and impact is low, then the risk level is considered as low. For example is major UI inconsistency in a mobile app that users rarely notice. Okay, it can likelihood of happening is very unlikely, but if it happens also, the impact is very less. This is because of the inconsistency in the UI. There is no the functionality loss. Then we consider risk level as low. This is how we basically visualize the different levels of risk based on the combination of likelihood and the impact. This matrix helps categorize the risks into low, medium, high or a critical level, so we can decide how much testing effort is required to test a particular feature. Now let us try to apply a risk-based testing by taking a real-world example. Let us consider you are testing an online banking application. The banking application has below features: the login, fund transfer, balance enquire, change password and download statement. Now we will going to analyze each feature for a risk. For that, we need to put them across the risk assessment table. This table basically shows a risk assessment for each of the feature that is under a test. This column shows a feature. This shows the two important components of risk called likelihood of failure and impact, and based on that we can derive the risk level for each of these features. This exercise is generally done with the help of the business team, the business analyst, product owners and development team along with the testing team to derive the risk assessment for each of the feature. This stage is called as an risk identification stage. For the logging feature, I have given the likelihood of failure as medium and impact of failure as an high. Login issues are moderate likely to occur. They are not consistently going to occur, right? Sometimes they may occur. This may be perhaps due to an authentication or a session management bugs. But if the user cannot log in, no other features can be used. Hence, the impact is very high. So, the risk level here is high. This is because a combination of medium likelihood of failure and high impact of failure, the risk level becomes high here. Fund transfer. Here we have given the likelihood of failure and impact of failure both as a high. Let us try to understand why is it. This is a core banking feature. It handles the money movement. So even a small failure, wrong account, double debit, timeout can lead to a critical financial loss. So the likelihood of happening is a very high because of many dependencies, and if it happens, it has a major or a high impact because of the financial losses. Okay, so we consider risk level as critical here. Balance inquiry have given the likelihood of failure as a low and impact of failure as a medium. So overall risk level is at medium. This is because the failures here are rare and don't block the transactions. But incorrect balance display can confuse the user and affect the trust. So likelihood of happening is a low, and if it happens, the impact is the medium. So we consider this as a medium risk. Change password. Likelihood of happening is medium. The impact is also medium. The password, this is because the password update issues may occur due to the validation or a security checks. The impact is moderate since user still can log in, but it affects the account security. So it is a medium risk. Download statement, likelihood is low, impact is low. This is so the overall risk level is at low. This feature is optional and usually well tested. Even if it fails, the user can still view the balances or transactions, okay, using an application, right? You need not have to download a statement to see your balances. You can also check them online. So the likelihood of occurring is a low, and if it occurs also, it has a least impact to the end consumer. So the overall risk is low. This is how basically if a number of the features are to be tested, then we need to identify the risks based on the risk assessment table with the help of many stakeholders like the business analyst, the business people, the product owners, the development team, etc. So far we understood what is the risk, what are the two important components of risk, and for a given the features, how to arrive at a risk assessment table, and how to give the risk level for each of these features. Okay, so along with that, we can also basically use a numerical model for more precisions. Okay, so we can also give a risk scoring. Okay, let us see how to do this. Risk scoring is nothing but giving a score to your feature or a functionality based on the likelihood and an impact. Based on the likelihood and an impact. Here each of the risk item represents a key functionality in an application. For example, fund transfer, login, change password, balance inquiry, and etc. Okay, and the likelihood and impact, both of them are rated on a scale from 1 to 5, where 1 means low and 5 means high. And the risk score is basically a product of likelihood and an impact. Let us take as an example of fund transfer, where its likelihood is 5. This is basically coming from the previous table, right? Where we have fund transfer, the likelihood of failure is high and impact is also high. So we have both of them as 5 and 5, and the risk score is 5 into 5, that is 25. That is a very high risk area and should get top testing priority here. On a contrast, the download statement is where the likelihood of occurrence is in 1 and the impact is 2. This gives us a score of 2, and it is a low risk item that can be tested with less priority. Overall, this is a simple matrix that helps the QA team to quickly identify which areas of the applications are more critical and where to focus their testing effort first. The high risks are always the scores above 15 should be tested thoroughly. The medium risk, the scores between 6 to 15 where we need a moderate testing. and the low risk areas where the scores are below 6 are called for a basic testing. That is how basically we assess and prioritize testing based on risk, likelihood, and on the impact. Based on the risk assessment table as well as on a risk scoring, we can do a prioritization in testing. For prioritizing a testing, we use a 4-quadrant approach in which the x-axis is basically talks about a likelihood of failure and the y-axis talks about the impact. So this is a y-axis and this is an x-axis. Okay, so we have a 4-quadrant. The first quadrant where both the impact and likelihood is high. This is where we basically fit the features that basically needs more testing effort. In our case, in our example, it is the fund transfer, right? So if the impact is high and the likelihood is low, that is the second quadrant where the prioritization or in risk level is the medium. So we can put all the medium risk level features into this quadrant. Here the impact is low as well as the likelihood is low, so we can put low risk features here. For example, the download statements. Okay, here the impact is high whereas the likelihood is low. So we can consider this risk level as a medium, and all the testing the features where the risk levels are low, we can put it into the 4th quadrant. Okay, basically we will allocate more testing effort to the critical features, that is fund transfer and to the login module, because the login module is also comes under the medium risks. The moderate effort is going to the balance enquire and for the change password. This is from here, right? This is taken from, these features are considered from here, and the minimal effort is put into the download statement. This ensures that critical business and customer impacting areas get the attention as they deserve it. So far we understood the theoretical aspects of the risk-based testing. So we understood what is risks, what are the main components of risk. We also understood what is a positive risk, what is a negative risk, how to basically give a risk score, how to identify the risk level, and so on. Now we basically come to a practical part, that is how we implement the risk-based testing. So here are the 5 simple process to follow when implementing the risk-based testing. First one is to identify the risk. It is the most critical part in implementing a risk-based testing. List all the possible functions, performance, and the security risks. Assess each risk. Now, once the risks are identified, then we will have to evaluate this risk, like how often this functionality is going to, this risk is or this functionality is going to fail, and if it fails, what is an impact on the end user. Now, based on this, we can prioritize the risks. We can give the risk score, or we can identify the risk levels. Then the 4th step is plan the test accordingly. Allocate the time and resource based on the risk priority. The 5th one is monitor and review. Continuously reassess as the new information emerges. So this should be risk assessment or risk identification should be an continuous process. It should not be an one-time effort, because we are going to add a new feature to the applications. So as the new information emerges, we again need to conduct the risk assessment. I will touch upon little bit in detail in identifying the risk, because it is a very important part in implementing the risk-based testing. If you don't identify the risk, then your entire risk-based testing implementation is going to fail. So the identifying a risk is a critical area. Before you even start writing a test cases, it is important to assess which part of the application carry an higher risks. These areas where the defects are more likely to occur or will have a bigger business impact. Some of the common risk areas are the complex features. The features that involve multiple workflows, calculations, dependencies. Example could be payment gateway integration, loan eligibility calculations. Why it is risky? This is because the complexity increases, there is a chances of more defects. Second one, features with many business rules. The features that are governed by detailed conditional logic. Example, tax computation module, discount rules in e-commerce application. Why it is risky? Small mistakes in the rules can lead to a major functional errors. Third one is the legacy features undergoing an enhancements. The old features that are being upgraded or refactored. Example, adding a new fields to a legacy report or upgrading authentication flow. Why it is risky? Existing functionalities may break. Integration with the new code may cause more defects. Fourth one, error-prone features. Features that frequently fail in production based on the past histories. Example, file upload, data import or export, report generations. Why it is risky? Historical data shows that they need more attention. Fifth one, high customer or business impact areas. The features critical to revenue or user satisfactions. Example, fund transfer in banking, checkout in e-commerce, booking confirmation in travel applications. Why it is risky? Failures directly affect the users and the business outcomes. Sixth one, integration points and third-party dependencies like APIs, external services, databases, or microservices integration. Example, payment gateway, shipment tracking APIs, social logins, etc. Why it is risky? External changes can cause the failures outside of your code. These are some of the references that you can use while identifying the features for the risk assessment. And also, to properly assess the risk, you cannot just look at the code. You need to spend a time with both the business stakeholders and developers to understand the business logic, to identify the critical force, to spot the complex or legacy areas prone to the failure, to estimate a potential impact if something goes wrong. This helps you to prioritize which areas you need to most thoroughly test even before a single test case is written. Now you know how to implement risk-based testing. It is important to understand the benefits of risk-based testing. This testing is focused on critical functionalities. Thereby, it basically saves you a bit of a time. Better resource utilization, faster time to market, improved defect detection in key areas because of our prioritization, transparency in test planning and prioritization. These are some of the key benefits that we can get by implementing a risk-based testing in your project. Adding to the benefits, we also have a key challenges in implementing a risk-based testing. The first one is identifying the risks, subjectivities in accessing the risks, changing business priorities, dependence on the domain knowledge, balancing the coverage versus effort. Overcoming these requires a great collaboration between business analysts, the product owners, developers, and the testers. Some of the real world examples where you can basically implement risk-based testing are: in a financial application, a fund transfer failure could result in a monetary loss and legal implications. That is why it should be tested across multiple browsers, high load, concurrent users, edge cases like transfer limits or invalid inputs. What I am trying to tell is this feature needs an high attention and it has to be tested thoroughly with the different configuration parameters. When writing a test cases, it is a good practice to label or tag each of the test cases with the risk priorities. Some of the tags could be like critical tests like R1, R2, R3 and R4. This tagging system ensures you always know which test must be run first in a limited time cycle. If there is a pressure on the test timing or If you don't have a much time to execute, then basically this best practice will help you to prioritize the test cases for your testing. Many of the test management tools like TFS or Azure Test Plan or the Jira, Zypher or an X-Ray basically provides a facility to tag the test cases, and you can also write a query to query all the test cases with the different priorities. Okay, this really helps you in executing the different priority test cases if there is a limited time given for the test execution. Now let us try to see how to integrate risk-based testing with test automations. So you have a list of test cases with the different priorities. Try to automate as much as possible the repetitive tasks, the low risk test cases and the medium risk test cases, so that no manual intervention is needed in the execution. Meanwhile, focus manual and exploratory effort on the high risk areas. Okay, don't miss testing the high risk features manually. The tools like Jira, Test Trial, Azure DevOps can store the risk scores and link them with your test management systems. That brings us to the end of this session. Hope you enjoyed learning with me. In case if you find this video helpful, please like and subscribe to my channel. Thank you for watching.